Hello, welcome to Career Tech Explorer, a channel that is dedicated to bringing you content on tech, engineering, and diverse advancements in technology in general. In today's video, we are going to look at how we can use R to perform 3-parameter logistic model analysis on educational data. Basically, the title says performing 3-parameter logistic model analysis in Rstudio. Performing this type of analysis has to do with we need at the beginning to know two concepts, one of which is called IRT and the next is the 3-parameter logistic model itself. Now, IRT is a short form of item response theory. Most of the times in item analysis in psychometrics, we use either CTT or IRT. Today we're going to be looking at what IRT is. But before I proceed, if you would like to know what CTT is, please leave me a comment in the comment section of this video and then click like, subscribe to my channel if this is the first time you're encountering it, and then let's proceed. So IRT is the short form of item response theory. It is a family of mathematical models that are used for analyzing the relationship between latent traits, that is unobservable traits or characteristics of an individual and their response to items. For instance, the answers they provide on a test. Now, there are diverse IRT models that are used in education, but one of the things you will note is that they are commonly used in educational settings, psychology, and other fields to design exams or to design scores assessments. Alright, so briefly we also want to talk about the 3-parameter logistic model. The 3-parameter logistic model, or 3PLM, is one of the commonly used models in IRT, which itself is an extension of a simpler 1-parameter hash and the 2-parameter logistic model, which incorporates 3 basic parameters. The first being difficulty index. This reflects how difficult an item is, which means that when a value is very high, it means that it is difficult, while when the value is found to be very low, it indicates that the item is easy. Then you have the B, that's the B parameter. The A parameter is discrimination index. This indicates how well an item is able to distinguish or discriminate between individuals with different levels of traits. It helps in suggesting the higher value of this particular index suggests that an item is better able to distinguish between higher achievers and low achievers in terms of taking the test. The third thing is the guessing parameter. This helps to account for the probability that a low ability test taker will guess the correct answer to a particular item in a multiple choice test. Why do we use the 3PLM? We use it because it provides a more flexible and realistic model for analyzing items, especially in the context of multiple choice tests, where guessing is possible. It also allows for a detailed understanding of how different items function across varying levels of test takers' abilities. It also helps in modeling the guessing test takers, ensuring that there is an improvement in the accuracy of the ability of the estimation, and particularly at the lower end of the ability spectrum. Where do we apply the 3 PLM? In educational testing, as we mentioned earlier, in psychometrics, in certification and licensure exams. There are 6 steps that we're going to discuss in the course of this short course. First thing is that you need to know that your data have to be prepared. Second step involves that you need to install and load the necessary packages in your Rstudio. Then of course you will load your data and prepare the data by separating the answer keys from the main data. Fourth, you will score the item responses. Number 5, you will fit the 3PL model to extract the relevant parameters and calculate them in a summary table. Last but not least is to plot the ICC, that's the item characteristics curves. We are going to move over to R now. Please, like I said earlier, if this is the first time you're encountering my videos, please do well to subscribe to this channel, hit the like button, and also share among your fellow psychometricians or students, so that the YouTube algorithm will continue to share my contents. Thank you. Now, the first step to do or to perform is to prepare your data as indicated earlier on your slide. To prepare your data, this is the data that was gathered from the tests, which we are using as an example. This is an example coming from electronics, basic electronics examination that was administered to 1,000 candidates. 1,000 candidates, right? And there are 50 test items. There are 50 test items, item 1 all the way to item 50. Now, in preparing our data, you are expected to include the keys. That means the model answers to this particular test. All of them should appear on the last row of your sheet. Then after you have done that, you now need to save your data in a CSV format. And to save your data in CSV format, what you do is to click on the file, and then you come to save as. And after coming to save as, go to the file location where you want your data to be stored. What we want to be saved in the live streams. Then you come down over to save as type, and then when you click on it, it will show you the diverse options that you have, and you select comma delimited, and then you click on save. Your data would have been prepared in the CSV format. I have done that previously. I'm not going to do that. So if you come over to my file, you will see quickly that my data called electronics test data is already saved in the CSV format. Of course, recall that this particular format is Excel format, and this is the CSV format. Next, we'll go over to Rstudio. This is Rstudio. We are now going to create a script. Creating a script, you come over to this icon, you see it showing new file. When you click on it, a new file will be opened up. Then in R, one of the first things you need to do, which is always outside what we are here to discuss, is to create working directory. And to create working directory, just simply type, just include the comment set working directory. This is to enable you remember what your line of code is doing. This is the reason why we include comments. Okay, so now not to waste your time, I am doing this, and so the function for setting working directory is set wd. As soon as you do that, you open the close bracket and then you come over to your file. Let's say this file, you right click on it in order to get the address, you click on properties, and then you come to where it is showing location. This is the memory location of your file. Copy it and then go back to R, include double quotation mark and paste what you copied into it. But then you have to change your slash or stroke signs. Let them be the forward facing clause. Once that is done, you have set the working directory to be the live stream environment. So when I hit on run now, you see that our working directory is set to live stream. That's the first thing we need to do. Then, of course, we are finished preparing our data. The next thing we need to do is to load libraries. Okay, now the libraries we are going to load are number one, the Psychometric library. Okay, pick library and use LTF. That's the first library we are going to use. Now, if you do not have it, you will need to come over to tools here, and then you hit on install package. When you open it, you type LTF here and you click on install. Then you would have completed the installation. The next library we are going to load is deploy R. So type in library deploy R. So you can see. And the next library is the main one. The main one, which is a psych. Okay. So these are the three libraries we need to load. So to effect the loading, we need to actually highlight and hit on run so that these libraries will be fully loaded. Now they have been loaded. The next thing we're going to do is to load our data. Now to load our data, we are going to just call that data, and then don't forget that this is how we assign variables, and then we're using the function read.csv, which is this. Okay, open quotation mark, open and close, and then we type electronics. Let's see, electronics tests data. Now don't forget that the type of file we're having is a CSV file, so it's going to be .csv. If you're in doubt of the spelling, you mustn't make mistake in the spelling. You come over to the data here and then you see properties. When it gives us, you copy the name of your file. That's one simple way to do it. When I paste it here, we're going to have the name to do this. But then don't forget to include .csv. It does not have a space, so it's .csv. This is how to load the data into R. Right? Upon running it now, we have been able to load our data into R. If you want to view it in the grid form, you just can say view data, and then and you hit on run. Your data will display. See that? This is our data. This is our data. Like 1 to 50. When you scroll down to right there. Scroll down to 1,000 responses, whereas this last one is the keys, as we said earlier. Now let's proceed. Then after loading the data, the next thing we're going to do is to separate. We're going to say separate the answer key from the main data, right? main data, and to do that, we're gonna write the line or the code that says answer key, that's underscore key, answer key assign variable as character. Because this time around we are using the function as character. Then you say on list, right? On list, open data, and then square brackets, the last row, which is the nth row of our data is what we are working on. So this will now be a comma, right? So when we run this, before we go on, we now implement that on the data, which is data square bracket, remove the nth row, which is the last row of our data. Okay, of our data. This removes the last row. So let's run this code and see what happens. Good. We have successfully removed the last row. If we are to still view the data now, view the data. So if we view it again, now remember we were having 1001 rows. This time around we are going to be having exactly 1000 rows. That is because the last row would have been successfully removed, as you can see. We no longer having 1001, having just 1000. So let's move over to continue. Now, having done that, the next thing we're going to do is to score our data. Okay, so score the data. To score the data, we're going to first write a function. So define, and just say like define the scoring function. Okay, now our function is going to be called score responses. Okay, it's going to be called score responses. This we're going to assign the following. So write the function. Okay, function will be responses, comma, key, and then we're going to use the wavy brackets, open, and then wavy brackets closed. Okay. After that, we are going to include what is your return. So we're using the function return. What is going to return? We use the condition if else. We're using the if else condition and say response, where response is equal to key. That should be scored 1, otherwise it should be scored 0. Okay, so now the facts. So let's push on. Now, having sorted that one out, we are now going to perform the actual So we're going to apply the function. So apply the, because when you design the function, we must apply it on the function. To apply the function, we're going to now call that one scored data, which is assigned as data dot frame, and we say apply the method. Okay, then apply score responses. That is this, that function. Apply that function. Score responses from our data as well as the answer key that we prepared over here. Okay, so having done that, we are now ready to score our data. If we now highlight the whole of this, go on. Object response. Okay, there's a mistake. We are supposed to have responses here, not response. Okay, so let's move on. Fantastic. The data is now scored. Then the next thing we now need to do is to analyze the data using the 3PLM. So we're going to write that here. We like to write the calculators and analyze the data using any parameter. So to do that, we're going to first fit the model. So we're going to fit the model. It's the 3PLM. The 3PLM model to the data. Okay. Now to do that, we're just going to write 3PL model. Assign variable and use the library LTM, function of the library LTM, and we say the scored data. Okay, and then use the tilde sign. Okay, tilde sign Z1 the capital letter IRT dot para, as you can see, and that condition should be true. Now once that is done, and we run that line of code, and we run that line of code, and we will have, there's a complaint. Let me see what's causing that. Let's see. Okay, it was a typographical error somewhere, so that has to be fixed. Good for it to run. As you can see, it's running. Now, as it is running, it's done running. We now need to extract our coefficients. Extract coefficients. And to do that, we just ask it to just write coefficients. In plural form. That should be from F as a function, and it should be done from the 3PL model, which we did before. So when we run it, if there's no problem, see that our code is blued out. So there's no problem, the next thing we need to do now is to create a table. Create a summary table for all of this data that we prepared. So let's say create a summary table for create a summary table for the results. Okay, and let our summary table be called results table. Okay, our summary table will be called result table, and then using the function data frame, right? Data.frame. The first thing we're going to do is for it to list the items in this test, and that will be the row names. That will be the row names of the coefficients. That's the first column. The second column will be difficulty index. Difficulty index, and that column will be generated from coefficients, and it will come from DFF CLT, that's difficulty method, falling now under discrimination. Discrimination index. That will be the column name, and that will be from coefficients. So then discrimination DCI. So these are the two parameters that I'm interested in. And then if I'm going to run this now, table will have been created. Okay, let's see what happens. Table. Okay, so a table will be created. Good. So a table will be created, but it's not yet displayed. The only thing you can do is you can ask it to create the table and call it results table. Go on this table. As you can see, table has been created, having each item here to each component again discrimination index. It is low, it means that it's easy. It is high, we can as well view it so that it will green lines. So we can ask it to view results table. We do that. Here is the grid for the gridded created. Okay, so as we proceed, please, if this is the first time you encounter this channel and you are enjoying the content of this video, please do well to hit the subscribe button. And I want you, if you are interested in having the guessing factor indices displayed here, type guessing factor in the comment section. I will do the video. I'll just write out the code for the script and send it to you so that you can perform it. Now the last thing, as we indicated on our PowerPoints, is to plot the ICC, that's the item characteristic curve. So that's the last thing. We will write plot the item characteristics curves. Alright guys, to do that is simple. It's just a simple line of code, and you just write big plots, and say 3PL model, or tell it the type, what type of plots it's going to do. It's going to do ICC capitals. Once that is done, and our ICC curve has been generated, as you can see. So this one is going to view what about is here. We're able to do that. So ladies and gentlemen, if you are interested in getting the interpretation of this particular form of analysis, type in the comment section the interpretation, and we are going to do the interpretation and share with you in fact, I've done it, and what I will even do is that I will create the interpretation and share the link in the comment section of this video. I will only do that if I am able to get 10 people who will type interpretation in the comment section of the video. Thank you very much, ladies and gentlemen, for being patient with me. God bless you. Bye bye.